Hello friends, I hope you all are doing great. I'm Gaurav Sahani from Captain Cook Knowing the World. Today we are back with our all new video in NetGRF series, that is Climatology. Today we're gonna study everything about the climate and around the earth with reference to climatology that will gonna come in NetGRF series. Friends, on the left top corner, it is our website, that is captaincookindia.wordpress.com. Read all the static contents, and due to some reasons we are not able to complete the all the topics on a particular video because it gonna be so lengthy. So we'll be gonna publish our website, which is over here, on 1st of January 2017 on the New Year Eve. So don't forget to watch this website and follow us on Facebook. We're gonna update each and every knowledge along with the video on Facebook. Do visit Facebook, our Facebook page, that is at Captain Cook India, and this is our subscriber button. Subscribe to our channel Captain Cook Knowing the World for all the latest updates and knowledge. And before going to start this climatology lecture, I want to tell you that do watch our previous videos that gonna make a proper sequence of knowledge to you, or whenever you're gonna study, or as you people are revising because of time, as this is almost end of December, you must be on revision state. So you can watch these videos in a sequential manner that can help you to revise. And I insist you guys to watch these videos on a repetition, minimum twice or thrice. That will increase or motivate your standard or motivate you for a particular topic. If you're not able to understand or if you have doubts, please comment down below or post it on our website or on Facebook page. Let's begin it. Today we're gonna cover these topics, these 9 broad topics, in which the introduction, composition, structure, heat budget, temperature, jet streams, winds, distribution of precipitation, hydrological cycle, and global warming are gonna cover. Introduction. What is climatology? It is a science that studies climates of various parts of the world with reference to the spatial and temporal regions and the climatic regions also. Atmosphere is an envelope or a blanket, we usually say, of air that surrounds the earth. Imagine this is earth and this is a blanket of atmosphere which is surrounding the earth. What is weather? It is the means of atmospheric condition of a particular place of a particular time. For a time being in a particular place, what is the temperature, pressure, precipitation, humidity, wind, and so on things are called weather. And for a climate, it is basically the state of weather or a particular weather condition, which includes temperature, precipitation, pressure, humidity, and so on things, which is appropriate or common for a particular place for minimum 30 to 100 years. That is known as climate. Like as an example, in Delhi, today's climate is cold. Like for today, in December month, it is cold. Wind is almost 20 to 30 kilometers per hour. Temperature is around 20 and humidity accordingly. So to that particular region, that particular temperature, pressure, humidity, and so on things are gonna be weather for today. And if that weather stays for 30 to 50 years approx, so that could be the climate of Delhi. Understood? And climatology is gonna be used, or people are using it in meteorology, in daily day-to-day met department of different states, earth, countries. Economy similarly, like fisheries and different Human life, we know it about the southern coast, and all the different things accordingly, which is with reference to human and nature. Earth and sun relationship, guys, we know whatever climatic condition of the earth is being today is is today is due to the relationship of sun only. As the first point is earth rotation and revolution. As the earth rotates and revolves around the sun, that is the reason the present climatic conditions are being in a change, or the weatheric conditions of day to day is change along with the seasons. Look over here. This picture shows the earth rotation and revolution. As we know it, earth rotates around the sun on its axis from north to south, sorry, from north to south. That is the moving, that's called rotation. It is, this rotation takes place almost in one day, approx 24 hours. It is 23 hours or something, 8 something like 50 minutes or so. So this revolution, so rotation gives you the time of one day, the day and moon similarly, and this rotation and this movement is called a revolution. Guys, what is perihelion? It is the smallest, it is the closest distance of sun and earth, that is on 3rd Jan, and this is aphelion. It is the longest distance, that is on 4th July between sun and earth. The tilt of earth's axis, as I've explained in my previous video of geomorphology also, that excuse me, sorry, that the earth is tilted on its axis, that is 23 and a half. And solstice, it is basically the movement of the earth which gives 23 and a half degree north, or the tropic of Capricorn is perpendicular to the sun, and this is called summer solstice. And when the tropic of Cancer is on perpendicular to the equator, it is winter solstice. Equinox is basically when the equator is perpendicular to the sun, sorry, to the sun, yes, and the time is 22 or 23rd of September, and different seasons are due to this, we know it. The composition and the structure of the atmosphere, guys, the composition of the atmosphere is due to two main gases basically, which includes nitrogen and oxygen along with the quantity. And the secondary phase, or the states of gases, which includes argon, carbon dioxide, hydrogen, neon, helium, ozone, and others. Guys, these two are making 99% and the rest are almost 1%. This diagram shows similarly as pi. Structure of atmosphere, as we know that the structure of the atmosphere is combined with 5 different layered spheres of the earth, which includes troposphere, stratosphere, mesosphere, ionosphere, and exosphere over here. As troposphere is the most important layer for the earth, because almost 75% of the gases which is needed by humans for living are present over here, and the average height of this is almost 18 kilometers. After that it is stratosphere, and sorry, in troposphere the temperature decreases, that is called the normal lapse rate also, as after every 1 kilometer 6.5 degree temperature Celsius is decreasing. and in tropopause that temperature or the stage is will be of 2 degree Celsius per kilometer. In stratosphere, this is another important layer, and uh, it got heat because it absorbs all the UV rays from the sun, and ozone is also present over here. The almost height is approximately 50 kilometers, and after the stratopause that divides all the pores which are being present in different spheres are the pauses basically which divides the different spheres from each other. After that, mesosphere, where the all the meteors are present over here and they cannot get into the atmosphere or the stratosphere. And over here, again the temperature increase from from 0 to -60, and over here it again rises up, and this is almost 80 kilometers. This is -100 approx, and this is at 400 kilometers. The temperature is over here is 1000 degrees Celsius. I've told you this again. Over here again temperature rises, and above it the satellites are launched over here around 6300 kilometers and so on. The combination of atmosphere is also important because of these three layers. We know it: 78, 29 around 3%. As on this, these cycles, the carbon cycle, the nitrogen and the oxygen cycle, is a combination of the cycles of different layers or different gases. Like in carbon cycle, we exhale carbon dioxide, we inhale oxygen, right? And the moment we exhale carbon dioxide, it is being exhaled by plants and trees, so that can be also treated and then given back, or when plants exhale oxygen, it is taken by us. So it is directly or indirectly proportional or interrelated to each other, and that gives rise to the proper circulation of different layers along with the important gases in the atmosphere. The heat budget, it is a very important concept because due to due to sun and heat only the life is over here, and earth traps the complete heat, and that gives energy to all the humans. As the terrestrial radiation, absorption of the solar radiation, we know it, and it is done by the albedos, the different albedos which intercepts the radiation or reflects the radiation. These are the following albedos you can study. Guys, I want to focus over here. This is very important as it regulates the percentage, as this is the accounting of solar radiations which is coming to the earth, which is reflected from the after that reflecting from the earth towards the atmosphere. Imagine solar radiation 100 units. The first 6 units are reflected by the atmosphere like this, cloud tops, remember. Then rest 27% is reflected by clouds. Another reflection by atmosphere, like the gases, different particles are present on the earth, so before reaching the clouds they reflect back. 27% reflect by the clouds and 2% by the earth surface. That could be the forest, that could be the sea, that could be sand or snow, can be anything. And trees, like canopy, the canopy of the trees reflects, or sometimes, and some percentage is basically absorbed by it. And almost 51% of the total solar radiation is being absorbed by the land or the surface. Then after, radiated from the surface to space is almost 17%, and radiated from the surface of the atmosphere, like which are being present over here, is 34%. The complete combination is 100, along with what is radiated from air to space, whatever is being present over here, like this. This gap shows this is present on the earth. So absorbed, this is outgoing long wave. Yes, the moment solar radiations comes from sun, they are in short wave, and when those radiations are reflected back from the earth are in long waves. That is it. So this complete diagram or flow tells you the heat budget, basically the accounting of solar radiations which are being absorbed by the earth and reflected by the atmosphere. The distribution of temperature, atmospheric pressure, and general circulation of wind. It includes temperature. What is temperature? First of all, it is a measurement of heat in a body, be it in the atmosphere or the earth, or any human being or living being. Guys, every body of the earth which is present on earth, name it as atmosphere or human life or anything, is having a heat, a particular amount of heat, and that heat is being measured by temperature, right? Celsius or Kelvin or whatever. These are of two types, horizontal and vertical, which include these following terms. Guys, I want to convey a message to you that in the very starting of the video, I've told you that we cannot complete each and every topic, whatever we are focusing or putting on slides, guys, because these individual topics like solar constant, altitude of the sun, distance from the sun, greenhouse effects, heat budget, adiabatic lapse rate, and so on things, these are the topics which are usually the PhD topics of individuals. So with this example, you can understand how broad or big these concepts are. So that's why we cannot complete this within a limited time. We can give you an explanation on our website. Do search it over here. Now back to it. The impact, basically this diagram shows the impact of horizontal and vertical distribution, that is of temperature. These are the waves or the solar radiations which are being, coming in the atmosphere of the earth. This is North Pole, South, and this is atmosphere. That's it. Pressure. What is pressure? Air has weights and it exerts a force on the surface of the earth. Okay, the force exerted on the surface by a column of air above it is atmospheric pressure or air pressure. Guys, air has a weight, we know it. Air has a weight. It exerts a force on the surface of the earth. That weight exerts a force on the surface of the earth. Cool. The force exerted on a surface of the earth by a column of air, that particular column of air of above it, to a particular area of surface, that pressure is called atmospheric pressure. Factors affecting pressure could be basically thermal control, elevations, and dynamic control. And the types of pressure are usually of horizontal and vertical. Horizontal is like this, the pressure of each and every particle which are present in the atmosphere, like in this hall, different wherever we are going, the horizontally, and vertical like this. To show you a diagram of global pressure belt, this shows the complete, like North Pole, South Pole, 0 degree, 30 degree north, 60 degrees north, 3 degrees south, 60 degrees south. This is equatorial low pressure along with subtropical high pressure, subtropical polar low pressure, and polar high pressure, something like this. These 30 degree are horse latitudes. I have a question for you guys. Comment down below, what is horse latitude? There's a story behind it. Explain it in the comment. Wind can be defined as a stream of air, we know it, in a fairly and well-defined direction. Okay, this is wind, fairly and well-defined direction. Winds are generated due to differences in pressure, yes, from one place to another. Is due to the changes in pressure from in a particular place to another, and then wind start moving. Air has a tendency to move from areas from high pressure to low pressure. Like over here, are you getting it? What I've explained you earlier in the previous slides. Similarly, like over here, the in the movement of the winds, Coriolis effect is very important, plays very crucial role in that. The movement of Earth, when the Earth moves, that generates an effect that is called Coriolis effect, under which the winds of northern hemisphere deflected towards right and in the southern hemisphere deflected towards left. Okay, that's called Faraday's law, very important. And there are two types of basically wind in a general manner. There are surface winds and non-planetary winds. Surface winds are also called planetary winds, which includes trade wind, mid-latitude westerlies, easterlies, and polar easterlies. These all are well defined over here in a diagrammatic manner. And non-planetary winds are seasonal winds, monsoon, local winds, and very mountain winds. Guys, the moment we'll publish our website, we'll be publishing each and everything along the diagrams over it. Don't forget to watch, because I'm not covering trade winds, polar easterlies, and mid-latitude and westerlies winds over here, because it's a long concept. It will take a diagrammatic view to explain, so it will be a very beneficial for you guys to watch. Thank you. In monsoons are also a kind of wind. It is basically a tropical wind system under which the direction of the tropical winds, and it is a part of seasonal winds, I've told you. It is a system and it is a type of tropical wind system. It affects the larger part of the earth, yes, and monsoon system is a summer rainfall. Okay, it affects the larger part of the earth, we know it, and the summer rainfall, which usually occurs, is a part of monsoon. Like in India, it comes from south west corner. The moment monsoon winds come, they goes from central to the west, sorry, east, and after east they move towards west and get deflected due to Himalayas. Jet streams are defined as narrow bands of rapidly moving currents of air with a velocity of 200 knots. It moves from west to east, and they include polar jets and subtropical polar jets. Static part again, read over there. The causes are pressure gradients, thermal gradients, and principle of geostatic winds. Also read over there, it is well defined. Fronts and tropical cyclones, I have explained temperature earlier. Fronts will include when two air masses having contrasting characteristics of which come into contact with each other, the two air masses doesn't mix readily, and a zone of line is of discontinuity is thus formed. In other words, in a simple words, the sharp boundaries of the two air masses are called fronts. Okay. Uh, Types of fronts are cold, warm, and occultated. Guys, this is a confusion topic. Cold fronts having the warm effect or warm zones, winds wala concept. Study this over here. I have personally made it very decently and very non-confusing manner. The moment you'll read, you'll get to know. Or if you guys know it, comment down below. Okay, in cyclones, they are the areas of low pressure surrounded by high pressure with rising in the central part. Like cyclones is a type of effect which is being usually generated where the high pressure in the center is surrounded by the low pressure surrounded part outside. That is due to Coriolis winds and tends of moving in a circular manner as Coriolis effects are generated due to the movement of the earth. Similarly, cyclones got usually moves in a circular manner. The direction of the wind in a circular is anti-clockwise in the northern hemisphere due to Coriolis force I have explained, and in the southern hemisphere it is clockwise. This is clock and this is anti-clock. This should be opposite for you guys. Okay. And the types of cyclones are temperate, extratropical, tropical, and equatorial weather disturbance. This is at around 0 degree. This is around 30 degree, and this is around 60. And tropical cyclones, this is around 30 to 60 degree each manner concept. Different types of words are being used for cyclones in different areas, which includes tornadoes, typhoons or hurricanes. Comment down below what all these things along with anticyclones I've explained over here. Thank you. Precipitation, a term refers to aqueous deposits of solid liquid phase falling from clouds onto the surface of the earth. A major component of is of hydrological cycle. When the precipitation is basically a phase where the solid or liquid amount of water or anything comes down to the earth's surface through the hydrological cycle. It's a process I will explain in the next slide. Are you getting it? This hand movements are showing a proper cyclic manner, which includes surface measurements. It is being measured by surface measurements, estimation using remote sensing. It's a very developing subject of remote sensing along with GIS. I'll be covering a complete study on it. I'll be explain everything about GIS and remote sensing. Don't forget to watch that video also. Global Precipitation Climatology Project. It is a NASA's project related to GIS and remote sensing, in which they measure global rainfall or precipitation on a very huge manner, in fact on day-to-day manner from year manner. Study on this about on Google. It includes the 4 different types, which are convectional, orographic, cyclone, and frontal precipitation. Read about it on our website. Thank you. This is our second last topic, which is second last topic, sorry, confused. Yeah, this is our second last topic, hydrological cycle, which is explaining you proper sequence of hydrology or water or H2O in a proper cyclic manner. Read over here. Water present in the atmosphere in 3 different types, we know it: liquid, solid and gaseous state, and the movement of the water combined with changes of physical state and geographical location. And that's called hydrological cycle. Just imagine some amount of water is located in African continent, and the moment it, due to a sun effect, the water rises, it condenses, and when air travels towards the European or mid west Asian part, or you call it India, it rains, but is changing the physical state of water and the geographical location. Physical state from water to drop or gas, then again water. That cycle is called hydrological cycle, and which includes evapotranspiration and runoff and infiltration. Guys, I've told you that these topics are of PhD topics usually, because they are so broad and they having so much big concepts. So read about it. Evapotranspiration is basically the transpiration, right, with movement of from land to earth, so to atmosphere, along with runoff. It is basically when the water cannot hold by particular ground, soil, or layer, above layer of the soil. It basically runs off. That's called runoff. And infiltration is basically absorbing the water from क्या बोलते हैं, soil, like in watershed harvesting or in stepwise farming. This infiltration or runoff, this infiltration is high and runoff is slow. Okay, see over here, it tells you each and everything about hydrological cycle. This is ground which is being infiltrated. This is groundwater. This is surface water. This is condensed or cloud form water. This is a proper cycle. The last one is global warming. Global warming is a gradual increase of the average temperature of Earth's atmosphere and oceans, which can be contribute to changes in global climate patterns. Gradual increase of average temperature is called global warming. That can be when the heat budget is being calculated. There is always some minute point differences in the term in the total accounting of absorption and reflection. There is less amount of radiations got reflected back. Very small amount of reflection or the solar radiations are trapped with the atmosphere. That leads to the heating effect, and there is a depletion of ozone layer. There's a hole which is study about Antarctica, you will get to know about it. So that depletion is giving rise to increase of this heat also. Then global warming could have disastrous effect. We know it on the environment, like polar ice is being melting. Read about Arctic and Antarctic. These are the two main continents, I would say, Antarctica and Arctic. They are very widely affected with global warming, and it would cause large scale species extinct and have serious impacts on human lives. We are facing it. Agricultural yields, yes. Freshwater availability, yes. Increase in spatial and quantitative rates, and disease vector and so on things. Finally, it will affect the human with its economy and energy. Guys, to stop this global warming, we are working on it. That's why we promote CNG and other stuffs. Stop using public personal transport, private vehicles. Use public transports. One, another one, less use LEDs in compared to CFLs and normal halogen bulbs. It will reduce emitting CFC, chlorofluorocarbons, and CFC gases are basically acting as trap to solar radiation. They trap solar radiation. They don't release them, and they hold it. And this is our final phase. I hope okay, that is it for today. I hope you like it. Don't forget to share our efforts. And this is very left top is our website. Do focus, do study on it. That is www.captaincookindia.wordpress.com. After that, there are different series of ours, along with in NetJRF top 10 series and Uttarakhand PCS series. In the center, we have Captain Cook Facebook page. Do like our Facebook page on our right top corner. That is @ Captain Cook India, and subscribe over here I hope you like it. Thank you for watching. Best wishes for your exam. Do well. Don't forget, I'm keep saying is, don't forget to like, subscribe, share, and follow along with comment down below. Thank you so much. Good day ahead. Good luck.